welcome to the 9th session on galvanic cells. This is a continuation of electrolytic concentration cells, but here we will be considering the concentration cells in which the electrodes are reversible with respect to anions. So far we have been dealing with electrodes which are reversible with respect to cations. So that is a difference here, but otherwise it is all the same. It is a concentration cell with transference. Now, this is an example for an cell constituting electrodes with respect to anions. This is an anode where we have silver chloride, in contact with aqueous solution of HCl having an activity A1. And here we have cathode HCl, which is in the aqueous state, having an activity A2 in contact with AgL solid and Ag. If you remember, this is a metal in contact with its insoluble salt. This is the insoluble salt, silver chloride, in contact with a solution of anion of the insoluble salt. This is the anion, this is silver chloride. We have an electrolyte which has got the anion Cl minus ions. Now, here in this case again you have a single line, or it can be represented by a broken line showing that these two solutions are in direct contact. So, this is again a cell with transference where the electrolytic solutions are in direct contact. Now, let us see what are the reactions taking place at the anode and the cathode. At anode, that should be an oxidation, and for oxidation what happens is the chloride ions from HCl, combines and with Ag, there is a silver metal, forming AgCl solid and the release of electrons. So, what happens is silver loses its electron to get converted into Ag plus, and then it combines with chloride ion to form AgCl solid. So, this is a process of oxidation, that is the anodic reaction. At cathode, silver chloride will take up electrons. So, that will be the reverse of anode reaction, and therefore, silver chloride, which is in the solid state, accepts electron, gets converted into chloride ions and Ag, where chloride ions are of activity A2. At anode, chloride ions of activity 1 is being consumed, while at the cathode there is a production of Cl minus ions of activity 2. Now, the overall cell reaction will be, you can cancel the same terms on both sides. Here we have a Ag, this Ag is cancelled, then AgCl solid, and electrons on both sides. And the final equation will be Cl minus of activity 1 giving Cl minus of activity 2. That is what written here. Cl minus of activity 1 gives Cl minus of activity 2. I am representing this as equation number 1 because this is one of the reaction occurring within the cell during the operation of the cell. Okay. Now, here we can see that here chloride ions are being consumed, and here at the cathodic compartment you have the chloride ions being generated. Okay. So, when a cell is operating, Cl minus ions are consumed at the anode while Cl minus of ions are produced, while when it is in the anodic compartment its activity is A1, and when it is in the cathodic compartment its activity is A2. Thus, the concentration difference will be set up between the cathode and anode, and therefore, surely there will be a migration of ions from anode to cathode as well as from cathode to anode too. Now, let us see how it occurs. At anode, the chloride ions are being consumed, And where does this chloride ion come from? That is from the HCl solution. So, from HCl solution, when the chloride ions are being consumed, these are chloride and these are the H plus. H plus ions are left back. So, when the cell runs, there will be an excess of H plus ions where at the anode. Okay. At the cathode, there will be chloride ions being produced, but they don't have any H plus ions to combine with them, and at the cathode, there will be deficiency of H plus ions. This is at the cathode. Now, what happens is that since this H plus ions are in excess and these chloride ions, they require H plus ions, there is a tendency of H plus ions to migrate from anode to cathode. So, this H plus ions can migrate from, that is from concentration A1 to migrate to the cathode. Okay, at the same time, at the anode, you have excess of chloride ions, right? But the activity is 2, and they tend to migrate towards the anode where they expect to combine with the H plus ions and then neutralize their charges. Okay, so there is a tendency for these two. So, what happens is that when 1 Faraday of current, I am passing 1 Faraday of current through that electrolyte, that is when I am performing that cell, you get 1 Faraday of current. That means you can say that there will be 1 gram equivalent of chloride ions of activity 1 consumed at the anode, while 1 gram equivalent of activity chloride ions of activity 2 will be formed at the cathode. So, at anode the consumption, the same amount will be formed at the cathode. Now, we are going to consider the transport numbers. Transport number of T plus and T minus are the transport numbers of T plus. I consider that to be of cation, and in this case it is H plus, and T minus, that is of anion. And what is transport number? It is a fraction of the current carried by an ion when 1 Faraday of current is passed. It's a fraction of the current passed when 1 Faraday, that is what we call it as transport number or transference number. So, when 1 Faraday of current is passed through the solution, that is it passes as the running of the cell, we have T plus gram equivalents of H plus ions migrating. At the same time, T minus gram equivalents of Cl minus ions migrating, and the direction of migration is as shown below. We know that anode we have an excess of H plus ions and they have got a tendency to migrate, and therefore, T plus gram equivalents of H plus ions will migrate from anode to cathode. At the cathode, we have excess of chloride ions and the migration will be T minus gram equivalents of chloride ions having activity 2. They are migrating towards the anode. And instead of T minus, I can put it as 1 minus T plus, because we know that T plus plus T minus is equal to 1. Okay. So, that is being written here. Now, I am going to express this in the form of an equation. T plus of H plus of activity 1, that is in the anode, goes to the cathode. When it reaches the cathode, the number will be same, that is number of equivalents of H plus ions is T plus itself. Okay. But the activity will be different, that is A2. Okay. So, 2 plus of H plus ions from the anodic compartment migrate to cathodic compartment, where it was activity was A1 in the anodic compartment, while it reaches in the cathodic compartment, it becomes A2. Okay. I am going to represent it as equation number 2, because this is also simultaneously occurring within the cell while the cell reaction is going on. Again, for chloride, I am going to take it in terms of T plus itself. 1 minus T plus of chloride ions of activity 2. Where is that? That is in the cathodic compartment. Migrates to anodic compartment. The differences, quantities remain the same, the ions are the same, but the activities are different. When it is in the cathodic compartment, its activity is A2. When it is in the anodic compartment, it becomes A1. Okay. Now, this also occurs, therefore, that is also expressed in the form of an equation, that is equation number 3. Now, the overall reaction taking place within the cell is the cell reaction, which we have already done with the cathode and the anode, plus the migration of the H plus ions and Cl minus ions. Okay. So, all these together form the overall cell reaction. So, I am going to add equation number 1, 2 and 3, and equation number 1, that is chloride ion activity 1 giving chloride ion of activity 2. So, the first one will be chloride ion of activity 1, and at the other side you can see that is the chloride ion of activity 2. These are from the cell reactions, plus this expression, that is T plus of H plus of activity 1. Okay. Okay. Then I have to write 1 minus T plus of chloride ions of activity 2, that is also written here with the arrow mark. In this cell it was chloride ions of activity 2, which is already written here. Then comes T plus of H plus of activity 2 plus 1 minus T plus of Cl minus of activity 1. So, all these are taken together. Now, what I am going to do is, I am going to expand this expression because of the brackets and all, and then solve it. So, first term will be Cl minus of activity 1 plus T plus of H plus of activity 1 plus, I am going to open this bracket, Cl minus of activity 2 multiplied 1. So, that becomes Cl minus of activity 2, and this is minus T plus. So, multiplying that, I will get it as minus T plus of chloride ion of activity 2. Okay. So, we have completed this side. Then I put the arrow mark, chloride ions of activity 2 plus T plus of H plus of activity 2 plus, I have to expand this, I will have Cl minus of activity 1, because in this case this I am going to multiply it with 1, then minus of T plus on, therefore that becomes minus of T plus into chloride ions of activity 1. Okay. Now, what I am going to do is, I am going to cancel the common terms, Cl minus of activity 1, see, Cl minus of activity 1, Cl minus of activity 1. So, it is here, see, I am going to cancel these two, Cl minus of activity 2. Okay. So, finally, we have T plus of H plus of activity 1 minus T minus of chloride ions of activity 2. Now, here this term is minus, so it is better I take this term to the other side. Similarly, here T plus of H plus of activity 2, this is a positive term, while this is a negative term, so it is better I take it on the other side. So, finally, I will get this as T plus H plus of activity 1. Okay. Now, only two terms are there. This term I am going to take to other side, and this term also I am going to bring to this side. So, this when comes over here becomes positive, becomes T plus of Cl minus of activity 1. Okay. On the other side, we will have T plus of H plus of activity 2 plus T plus of Cl minus of activity 2. Okay. So, this you can take this as T plus of H plus activity 1, both are activity 1. Okay. So, I can write this as combining these two ions together, I can make it as HCl. So, it becomes T plus of HCl of activity 1 gives T plus of HCl. Here it is, both are A2, one is Cl minus, the other one is H plus. So, this becomes T plus of HCl of activity 2. So, this is the overall reaction. We have been combining the cell reaction as well as the transference of ions across the liquid junction on the both the sides, and considering all that changes, we are taking the overall reaction taking place within the cell, that is T plus of HCl of activity 1 getting converted into T plus of HCl activity 2. T plus, that is in the anode. Anode is being converted into cathodic HCl. That means there is a decrease in HCl in the anodic compartment, while there is an increase in concentration at the cathodic compartment. Okay. Or you can say that T plus gram equivalence of H plus and Cl minus of activities 1 has been transferred from cathodic compartment to the anodic compartment, where their activities are A2. That is, when it moves to cathodic compartment, the activity changes to A2. Okay. Now, again, in the cell reaction, since it is involving only one electron, the value of N is 1. Okay. So, I will put it as N is equal to 1, and E naught of cell for all concentration cells, that is equal to 0 volts. So, Nernst equation will be E with transference is equal to minus 2.303 RT by F log. Now, here we have seen that on the product side it is A2, and in the reactant side it is A1, provided it is not 1 but raised to the power T. This is the number of equivalents that has been transferred. So, I have to raise is to the power T plus. So, A2 divided by A1, for both the cases that will be T plus. So, I have taken it as common term as T plus as their power. Now, reversing this term and removing this negative sign, we have 2.303 RT by F log A1 by A2 whole raised to T plus. Now, again for this EMF to be positive, only if EMF is positive there will be electrical energy derived from the cell. Now, if that has to be positive, numerator should be greater than the denominator in the log term, or you can say that A1 is greater than A2. What is A1? That is the concentration of HCl in the anodic compartment should be greater than concentration of HCl in the cathodic compartment. Okay, only then that will be positive. Now, in general, ET is equal to T plus the 2.303 RT by NF. In the other case, the value of N was 1, and here we have taken it as N log A1 by A2. Now, what we are going to do is again convert these activities in terms of mean ionic activities, and again I will remind you here that in this case you can see that it is both ions H plus as well as the Cl minus ions are involved in the electron reaction. So, when I am going to take it in terms of mean ionic activities, that is activity of HCl is equal to activity of H plus into activity of Cl minus. And instead of activity of H plus and Cl minus, I am going to take mean ionic activities, that is A plus or plus minus, and here also A plus or minus. So, multiplied you will give A plus or minus square. Remember, there is a square term. So, when I am going to replace the activity of the electrolyte by mean ionic activities of each of the ions we are considering, we get ET is equal to T plus 2.303 RT by F log, Here we have mean ionic activity of concentration represented by 1 and mean ionic activity of concentration represented by 2 whole square. Taking the square over here, you will have ET is equal to 2T plus 2.303 RT by F log A plus or minus 1 divided by A plus or minus 2. These are the mean ionic activities. Here, just note there is an appearance of 2T plus. In the other case, it was only T plus because we were considering only the activities of the whole electrolyte, which involves both H plus and chloride ions together. Okay, in the general form will be ET is equal to 2T plus 2.303 RT by NF log mean ionic activity of 1 divided by mean ionic activity of 2. It's a very important equation. You can remember that always. Now, again, we are going to consider that in terms of molalities. We know that activities are product of activity coefficients with molality. So, activity of H plus can be written as activity coefficient into molality. Again, that of chloride also it will be activity coefficient into molality, where that is equal to gamma square m square. Okay, substituting that, E with transference is equal to, since the square terms comes over here and I am going to take it at the beginning just as we have done for the mean ionic activities. So, it becomes 2T plus 2.303 RT by NF log gamma 1 M1 divided by gamma 2 M2. Again, we have the 2T minus over here. So, to conclude, here we have been considering the cell with transference where the electrodes are reversible with respect to anions. Okay, the Nernst equations are ET is equal to, T stands for with transference. Okay, T plus into 2.303 RT by NF log A1 by A2, A1 by A2. What is this in terms of electrolyte? Activities in terms of electrolyte. When these are in terms of mean ionic activity. Okay, in that case, remember you have 2T plus 2.303 RT by NF log mean ionic activity of 1 divided by mean ionic activity of 2. Again, when I take it as a product of activity coefficient and molality, again it becomes 2T plus 2.303 RT by NF log gamma 1 M1 divided by gamma 2 M2. So, that is all with this session. Thank you.